Inverse operation. Your learning target today is I can use the inverse operation to find the related multiplication and division equations. And you'll know you're successful when you can use the inverse operation as well as find the unknown in a multiplication or division problem. So today we're going to be talking about the inverse operation. And inverse operations are in any operation that we have done in math. So with adding, subtracting, multiplying, and dividing, those are all inverses, which is another word for sign, and those are all the signs that we use in math. With the inverse operation, we have learned before that when we add, we can use subtraction with the same numbers to figure out if we were right with our answer. Just like when we multiply, we can divide. We can do the inverse operation by switching our sign and checking our answer and also noticing our fact families. So remember what we did when we do adding and subtracting. This is an example. If I use the inverse operation with 18 minus 9 equals 9, what would be the inverse operation? I switch my sign to an addition sign, but I would do 9 plus 9 is 18. I'm using the same numbers, having them be in a different order and using a different sign. So if I see inverse operation, that means I am going to switch my sign, in this case from a subtraction sign to an addition sign. Let's do that today with multiplication and division. So with the inverse operation, when I multiply, I have my factors, which are my smaller numbers. A factor times a factor equals a product, okay? And then when we divide, we have to, of course, just change the order of our numbers using the inverse operation. So in this case, I am going to have our 28 be first because whenever we divide, we always have our big number first. And that will be divided by one of these small numbers up here. I could do a 7 or I could do a 4. I can do both, right? I will just do the 7 because that's one way we could do it. And what will that equal? That'll equal our quotient. And our quotient is the other small number, 4. So by doing the inverse operation, not only are we switching our signs, but we switch the order of our numbers. So you know that for that last problem we had 7 times 4 was 28. And we did the inverse operation by doing 28 divided by 7 is 4. What are some other ways that we could rewrite that problem, though? If I think about my fact families, which we'll actually be going over a little bit more tomorrow, I would just have to use the commutative property for multiplication, switching my factors around, but having the same product. 4 times 7 equals 28. And for division, we know that the 28 still goes first, no matter what. But I could do divided by 4 equals 7. That's our fact family, and we use the inverse operation when we switched our multiplication sign to a division sign, and the order of our numbers is different, but they're the same numbers, okay? Just a different order. So this time for the inverse operation, let's try it one more time. What does inverse operation mean again? It means I'm going to switch my sign, and we're going to switch it from a multiplication sign to a division sign because we know multiplication and division are related. So we switch our sign, and then what? Would it be true if I were to do 9 divided by 9 is 81? Is that true? No. Remember, not only do I switch my sign, but I change the order of my numbers. So 81 always goes first because it is the big number. Divided by 9 equals 9. That would be our way of doing the inverse operation. Same numbers, different order, and different signs. What if I have to do the inverse operation, but I have a division problem first? Uh-oh. Well, I'm going to switch my sign. And then what order would I put that in? The small numbers have to go first. 6 times 3 equals what? 18. Our big number. There it is. Or what's another way I could have written this? 3 times 6 equals 18. Just like we know up here that we could have written it as 18 divided by 3 was 6. So not only did we just do the inverse operation, but we have our fact family. So this is the part where I'm going to want you to try out these 2 problems this time. And I want you to use the inverse operation both times. But you'll have to do an extra step that I did not show in the video. And that is to use a strategy and find out the missing number. In this case, I want you to find the product for 3 times 4 and then use the inverse operation. And for 44 divided by 4, I'm going to want you to find the quotient. And also use the inverse operation. And tell me one way that you could rewrite that with the inverse operation. If you want to give me all the ways, please do that if you would like, because that's really good practice for tomorrow when we have to work with fact families. But please at least try to do it one way and use the inverse operation. So pause the video and try this on your own. Okay, first you should have definitely found the answer to each question. So for 3 times 4, you should have found the product, and you should have gotten 12. For 44 divided by 4, you should have found the quotient of 11. That would be the first step. Next step is to use the inverse operation. Let's do it on 3 times 4 first. Inverse operation means I'm going to switch my sign from multiplication to division. And now I need to put my numbers in the right order. So I know this is my big number, 12, so that should go in front of my division problem. And then I can do 3 or 4. I'll just do a 3. And that equals 4. You could have also written it as 12 divided by 4 equals 3. Okay? And if you wanted to find the fact family, like I said you could do, the only thing left we have to write is 4 times 3 is 12. So you have 4 different facts, but they are the same thing, right? These are the same, and these are the same, and we know they're all related. Okay, now for 44 divided by 4 equals 11. If we use the inverse operation, we have a multiplication sign now instead of division. And we know that the product is the big number. What's the big number in that division problem? 44. So you could have written that as 4 times 11 equals 44, or 11 times 4 equals 44. We know they mean the same thing, that it doesn't matter the order of those numbers. And if we took it a step further, your division problem, how else could we write that division problem? 44 always has to be in front, divided by 11 equals 4. That would be your fact family if you decided to do that. So today, that's what your job is, to practice the inverse operation And tomorrow we'll be working all on fact families. So remember, your learning target today is I can use the inverse operation to find the related multiplication and division equations. And you'll know you're successful when you can use the inverse operation as well as find the unknown in a multiplication and division problem.